Hi everyone, hi friends, hi my viewer, hi my friends. If you have been following my previous video, you know that I am doing a course on UPSC previous year's question paper. So in this video I will discuss 2017 Civil Service Mains paper Physics 2. So one by one discuss paper 2. This is quantum related quantum physics and solid state, so quantum physics. So here content which may be needed. And so first here you see question first. A beam of 4.0 keV electron for a source of incident on a target 15.0 centimeter away. Find the radius of the electron beam spot due to a Heisenberg uncertainty principles. Question B. Calculate the lowest energy of an electron confined to move in one-dimensional potential wall with 10 nanometers. So this is 10 mark questions. You see this. So obviously not estimate the de Broglie wavelength of electron orbiting in the first excited states of the hydrogen atoms. Question D. So that the lines in a observation spectra corresponding to the rotational transition from two adjacent energy levels of a medium-sized molecules at a room temperature have comparable intensity. And question number is, given the force constant of HCl molecules is 516 nanometer, so Newton meters, determine the wave numbers of fundamental mode of vibration of the molecules. How many transition lines one can expect in the vibration of spectra of HCl molecule at the room temperatures? And 2a. Evaluate the most probable distance of the electron from the nucleus of a hydrogen atom in its 2p state. What is the probability of finding the electron at the distance? Question number 2. Using Schrödinger equation, obtain the eigenfunction and eigenvalue of the energy for one-dimensional harmonic oscillators. Sketch the profiles of eigenfunctions for the first three energy state. And question number 6 here you see, calculate the probability of transmissions of an electrons of 1.0 eV electron volts. So energy through a potential barrier of 4.0 eV electron volts and 0.1 nanometer width. Question number 3. Explain Stokes and anti-Stokes Raman scattering with the help of the energy level diagrams for diatomic molecules. Obtain expression for a transition energy of its Raman spectra with rotational fine structure, and hence the wave numbers of the Stokes lines. 3b is here. Explain why the lines in a some Raman spectra are found to be polarized to different extent, even though the exciting radiation is completely unpolarized. 3c. State from quadrant principles. Define from quadrant factors using the systematic diagram. Explain the decay of excited state leading to the phenomena of fluorescence and phosphorescence. So this is BPI topics. You can see this read syllabus video in my channels. Question number 4. Explain why the square of the angular momentum L square, and only one of the component Lx, Ly, Lz of L are regards to constant of the motions. So this is commutation relations. So come to the fourth question. Explain the principle of nuclear magnetic resonance. So this is NMR, nuclear magnetic resonance. With the help of the energy levels diagrams, give the example of nucleic which exit NMR with the major interference can be drawn from a NMR spectra. In a NMR experiment, hydrogen atoms are subjected to a magnetic field of 5.0 temperature. Determines the difference of energy kg moles between two spin states of the nucleus of hydrogen atom and the frequency of the radiation required. So this is the related of topics nuclear physics, and next section B is here. Estimate the order of nuclear radius of LED Z is equal to 82 using the large angles back scattering of alpha particles of energy 10 mega electron volt on a target incident on a target lead. Given that distinguish between charge independence and charge symmetric of a nuclear force. Give one example for each of these. And 5 says here, describe briefly how periodic evolution in the beta decay was experimentally observed. What do you understand by the statement neutrino are left-handed? And 5D is your question. You see, bro, the energy vector E and wave vector K for a conduction band electrons in a semiconductor are related as E is equal to alpha h cut square k square by m0, where alpha is a constant and m0 is free electrons mass. Calculate the effective mass of the electrons. And 5B is here. You see this is useful data. So consider a operational amplifier circuit is given above. So here above, given R1 is equal to 10 kilo ohms and R2 115 kilo ohms, and the product of the open loop gains of the amplifier and its bandwidth 10 to the power 6 hertz determine the closed loop bandwidth of the amplifiers. And question number 6a, here you see, write the property of the neutrino which support to existence of non-central tensor force. Give the neutrino magnetic moment operator. I, an unit of nuclear magneton, can be expressed as, so mu d vector is equal to mu n sigma n plus mu p vector sigma p plus 1 by 2 L. So where L is the relative angular momentum between the neutrino and proton, sigma n and sigma p are the Pauli spin operator, and mu n and mu p are the respective magnetic moment. Find the d state probability of neutrino wave functions. So this is derivations parts. Question number 6b is here. How does one explain the experiment constancy of average binding energy per nucleon Be upon A? The nucleus of nuclei in the region 30 is less than A and less than 170 in the pollet of Be upon A versus mass number A. Question mark. Write the same empirical mass formula. Point out the role of the volume term, surface energy term, coulomb, and symmetric energy correction terms. And question number 6C. Here you see. States the three characteristic property of a strong, weak, and electromagnetic force, distinguishable one from the other. To point out of the interactions in which the following conservation law are obeyed or violated. Also, topics spin, hyperchange, lepton number, charge, conjunction. So hyperchange. Write down a quark constitute for each of the following: pi plus, k plus, delta plus plus, e summation 0 or minus. 7a. A system of paramagnetic atoms n per unit volume which can occupy only two energy levels in a uniform external magnetic field is at a temperature T. If the system follow Boltzmann distribution, find the magnetization and susceptibility of the systems. So question number 7b is here. Obtain the expression for penetration depth using London equation superconducting and explain its significance. Question number 7c. In a semiconductor, the effect of the masses of an electron and a hole are 0.07 m0 and 0.4 m0 respectively, where m0 is the free electron of mass, assuming that the average reaction times for the holes is half of that for the electrons. Calculate the mobility of the holes when the mobility of the electron is 0.8 meter square volt minus 1 s power minus 1. So you can say this is useful, and question is below. So an amplifier in a common emitter configuration in the above figures, if the circuit gain beta is equal to 100 and the AC alternating current emitter resistance is 25.0 ohm, determine the input impedance and the voltage gain of the amplifier. So 8b is here. You can see this. The question is given below. Given above a circuit of a cell based P channel JFET, if a pinch of voltage is 5.0 volt and VDS is equal to 6.0 V, calculate the saturation current IDSS. Question number 8c. Draw the systematic diagrams of the single particle energy level in a cell models, including the effect of spin orbiting couplings. So how it explain the magnetic numbers of nuclei? Give two examples to show how these schemes predict the spins and particles of the odd A nuclei. So I hope so that is all related to this is it for today. Thank you very much, my friend, my colleagues should